Let's get into one of the most relevant sections now of mathematics, and that is the section of financial maths. So there are two formulae that we were introduced to last year already. There's the formula for simple interest, and there's the formula for compound interest. So first things first, let's just have a look at exactly what the difference is between simple interest and compound interest. All right, well here it is. Simple interest. Interest is earned on the amount of money you initially invested. So if I open an investment account and I invest 500 Rand, then every year the bank is going to say, well, here is some interest for you. Let's say it's a 10% interest. So that means I'm going to be earning 50 Rand. Every single year I'll get 50 Rand extra into my investment. Okay. But they're still going to keep it at 50 Rand because it's based on that initial 500 Rand that I invested. Compound interest, what they do is they add that interest. So possibly in the first year I earn 50 Rand, but then next year they're going to say, okay, we're not going to work it out based on the 500 Rand you've invested. We're going to say now you are sitting with 550 Rand in the bank, so we're going to work out your interest based on that new balance. Okay, so the interest is then compounded, or at least it's added to the balance of money in your account. Okay, another thing we need to know before we dive into too many examples is what each of these variables represents. So here's a breakdown. A is the future value. So basically, if you invest today, how much money will you eventually end up with? It's the accrued value. It's a very fancy English word there. The accrued amount that you'll have at the end of the day in your accounts. P is the present value. So the amount that you're going to invest today. If you invest 20,000 Rand, then today the P value there is 20,000 Rand. I is the interest rate, and we need to put that in as a percentage. So if they give us a 10% interest rate, we can't just write 10. We need to either write 10% or 10 over 100, because percent means over 100. So they'll often give us an interest rate, and we just need to remember to pop that over 100. Okay, and then N is the number of time periods, which for now is just the years that we're going to invest something in. But what you'll see is that as you grow in your knowledge of financial maths, we're going to start investing things that earn interest every month or every quarter. And so that's why we've kept this as N, which can then change. You might have 12 months instead of 1 year, but that's going to come only in future questions. Okay, now that we have this knowledge, let's dive into some examples. You have been given 2,000 Rand to invest for 10 years. Which option is best? So we've got two options here to consider. Option A, where we've got 7.1% simple interest per annum, or option B, where we've got 6.8% compound interest per annum. So let's calculate, and then we can make a decision as to which one is best. Okay, if we are investing money, then the best thing would be to end up with more money at the end of the day. If we are borrowing money, then we actually want to end up paying as little as possible back, and so that's how we would then consider it. So whenever you're working with financial maths, it's good to contemplate your answer and then decide if it makes practical sense. Okay, the first thing we need is the formula. So this is a simple interest question, so A equals P, 1 plus I times N. All right, now A, that's what we want to know. How much will we end up with? P, we've got the 2,000 Rand, no matter what type of investment we choose. And then 1 plus, here's our interest rate, 7.1%, so 7.1 over 100, times by 10 years. Okay, 10, I'm writing it like that because I always think of a fraction times a fraction. But essentially, your calculator can do all of that for you, so you don't need to write it over 1. So we type this into the calculator, 2,000 brackets 1 plus 7.1 over 100 times by 10, and we end up with a final answer here of 3,420 Rand. Okay, so that's option A. Option B, we've got a different formula. A equals P, 1 plus I to the power of N. Okay, present value, we are still investing 2,000 Rand. 1 plus, the interest rate here is 6.8%. Okay, so initially we might think, oh, well, compound interest is definitely going to be better, but the interest rate is a little bit lower, so let's not be too sure of ourselves. Let's pop that into the calculator. So 2000 bracket 1 plus 6,8 over 100, and that whole bracket is to the power of 10, and we get an answer there of 3,861 Rand and 38 cents. Remember, we round off to 2 decimal places because it's rands and cents. And so now we can conclude option B is definitely best because it makes more interest. Okay, here's another example. Sam would like to go overseas in 7 years' time. He finds an investment account that offers an interest rate of 8.3% per annum, compounded annually. So they might not specifically tell us now to use the compound interest formula, but the fact that they have specified this interest rate like this means that this is a compound interest question. Okay, how much money should he invest now if the travel agent says that he will need 52,000 Rand for the trip? All right, so the formula looks like this. A equals P, 1 plus I to the power of N. And I find it very helpful to then just look and say, okay, what do I have in this question? Because it looks like a bit of a more complex than the previous one that we did. Okay, he wants to go overseas in 7 years' time. So that's the N value there. He finds an investment account that offers him an interest rate of 8.3%. How much money should he invest now if he needs 52,000? Okay, so in other words, what present investment should he do so that one day he ends up with the 52,000 Rand? And so by doing that, I can see, there's my question. They want to know what is the present value. So now we're going to substitute in. So 52,000 Rand equals P, 1 plus 8.3 over 100 to the power of 7. Okay, and now what we want to do is we want to end up with as little rounding off in between as possible. We want our answers to be accurate. So what I suggest you do is if you can identify the fact that in this question here, P is multiplying by this bracket, then what we can do is we can divide by this whole bracket to get P on its own. And because it's an equation, what I do to the one side, I do to the other side. So I'm not going to round anything off. I'm actually going to put all of this information into one calculation on my calculator. And so I'm left with P on its own here on the right-hand side. Let's type the rest in. And there we get an answer. It's a money answer. So 29,758 Rand and 3 cents. So that's how much money he needs to invest now if he wants to be able to afford this holiday in 7 years' time. Now let's see if we can really get our brains going. Here's another example. Ayanda is looking into various investment options. What simple interest rate would allow him to double his money in 10 years? All right, so like I said, I generally like to start by writing down the formula. This is a simple interest question, so 1 plus I multiplied by N. And then the other thing that's helpful is to pop down all the variables here on the side so that we can see what we need. Okay, so let's read. Ayanda is looking into various investment options. What simple interest rate, so there I can see the question, there, question mark, would allow him to double his money in 10 years. So there I can see 10 years. Okay, but now we're sitting with a predicament because all I know is this money needs to double, but I don't know what it is. Okay, and they like to ask us this question because they want to check, can we think outside the box? Okay, and essentially, no matter what amount of money he puts in there, it needs to double. Okay, so the very mathematical approach would be to say, well, then let his present value be X, and then double that to X, his future value. Okay, but if this is very scary for you because now we've got algebra on top of financial maths, you could essentially put any amounts of money in there. You could put 1 Rand and 2 Rand, or 100 Rand and 200 Rand. As long as the future value is double, you'll be able to work that out. Okay, so let's now calculate by substituting in what we've got. So 2x, his future value, is equal to x. 1 plus, the interest rate there is what we want, multiplied by n, so multiplied by 10 years. Okay, now we're going to do some equations. X1 plus, this is going to be 10 I over there. And now what we want to do is we want to try and get this, first of all, this bracket on its own, and then we'll work towards getting I on its own so we can solve it. Okay, so the first thing we want to do then is divide by x. What I do to the one side, I do to the other side. So those will go away. Those will also go away. So we have 2 is equal to 1 plus 10i. Okay, now we're going to move this 1 across. It's going to become minus 1 on that side. So 2 minus 1 is 1 equals 10i. And then we're going to divide both sides by 10. So now I can see that I is equal to 1 over 10 or 0, 1. Okay, but what they did ask us for here, grade 10s, is a simple interest rate. And so the fact that I've got this means that it has been divided by 100. So I need to then say, okay, well, to answer the question, therefore, the interest rate is going to be 0, 1 times by 100, which is equal to 10%. Okay, so however you end up getting from here to here, it's not necessary to show all this calculation, but it's important that you know that this I value is a representative as a percentage, and so that means it's out of 100, and so to get the interest rate, we multiply by 100 over there. Now, in this section of the syllabus, you can also expect to see some very fascinating real-life scenarios. Okay, so the section is actually called Finance and Growth, or Finance, Growth and Decay, when you start moving more into the senior grades. But what that means is we can look at growth that follows either a compound or a simple interest pattern. Okay, and so although this doesn't have any money in it, this example, it is the same principle, a financial maths principle, that we're going to use to solve it. So Mary is studying bacteria in a laboratory. She notices that the bacteria cells increase at a rate of 63% per day. Okay, this is where we really need to be alert, because we need to, this is an application of our financial maths. Okay, in a controlled environment, that's obviously in her lab. If there are 12 cells today, how many cells can she expect to see in 3 weeks? Okay, so now let's think about this. Bacteria, basically every time there's a new bacteria, that bacteria is going to multiply. Okay, so this is definitely going to be a compound interest question. And so let's start by putting the compound formula down. So A equals P, 1 plus I to the power of N. And then to guide us along, let's check what information we've got. So A, that's what we want to know. How much bacteria is she going to have in 3 weeks' time? Okay. P, we've currently got 12 cells. I is the interest rate. So that's a huge rate there of 63%. And then N, 3 weeks. Now, be careful. When we read it, I specifically said, per day. So generally, I'm used to annual change. And so I would say, well, how many, 3 weeks in terms of a year is 3 out of 52. But because this interest rate is daily, we need to give this N value as number of days. So how many days are there in 3 weeks? Well, there's 7 days in each week, so 21 days in total. And as long as this is a rate per day and this is a number of days, then we know we are on the right track. Okay, so that's the big trick there, is to make sure that you are adapting the formula to fit the information of this real life scenario. Okay, so 12 cells, 1 plus 63 over 100 to the power of 21. Let's calculate. I have a feeling we are going to end up with a large number of bacteria. So 1 plus 63 over 100 to the power of 21 gives us an answer there. Oh, that is huge. And this is why we need to wash our hands. 342,863,25 bacteria. Okay, and realistically, you're not going to have a 0.25 of a bacteria. So what we do in these type of questions is we round off, and we'll need to round up just to be safe. So it might not make sense to say 0.25 rounds up in terms of rounding, But you can't have a quarter, and if we were to round down, then we might just be working for too few. So in this instance, if you've got part of a whole, you're better off rounding to the nearest whole. Okay, so round up there, 342,864 bacteria cells that started from a measly 12 cells.